Let's now take a look at a different type of reasoning problem. Now what we're concerned about is whether the problem we're thinking about is abstract or concrete. Let's take a look first at an abstract problem called the 4-card problem. There are going to be 4 cards, and you're to decide which ones to turn over in order to see if the specified rule is being followed. So here's our rule. If a card has a vowel on one side, it must have an even number on the other side. Okay, so that's the rule. Now let's take a look at our 4 cards. We have A, 6, J, and 7. So every card has a number on one side and a letter on the other side. And once again, our rule is if it has a vowel on one side, it must have an even number on the other side. So go ahead and take a moment and figure out which of the cards must be turned over to see if the rule is being followed. So you may be thinking, check the A card, because the rule says if it has a vowel on one side, it must have an even number on the other. So you might need to flip this A over to see if there's an even number on the other side. So that's an example of one of the cards that you might choose to turn over to see if the rule is being followed. Let's take a look at what most people do. So 46% say that both the A and the 6 cards must be turned over. So let me go back and take a look at those. So 46% of participants say that these 2 cards need to be checked. 33% say that just the A card has to be checked. And 4% say that both the A and the 7 must be checked. So let's take a look here, A and 7. So this problem can be challenging for people. Let's take a look at a very similar problem that feels much easier because it has a familiar context to it. Now the context is that we're dealing with a rule about drinking and the drinking age. So the rule is if a person is drinking beer, then the person must be over 21 years of age. Your job is to see which cards must be turned over to test this rule. So the card has information about what a person is drinking and on one side, and then it has information about their age on the other side. And when participants are given a problem in this format, we tend to be pretty good at figuring out which cards you need to flip over to see if this rule is being followed. So we zoom in fairly quickly on this one, that if the person is drinking a beer, we better flip the card over to make sure they're over 21 years of age. We come here to this card and we quickly realize we don't care what the 22-year-old is drinking, right? They can drink beer or they can drink Coke, it doesn't matter. We also don't really care how old the person drinking a Coke is. But we might want to check to see what beverage the 16-year-old is drinking. And so people tend to perform pretty well on the problem when it's based on following the rules about having a legal drinking age. So with the familiar context of a drinking age, 73% of participants know the correct answer. That was drinking a beer, this first card, and check the person who's 16 years of age to make sure they're not drinking a beer. So we need to check the age of the person drinking a beer and check the beverage of the 16-year-old. And so the majority, 73%, do pretty well on this. Turns out that the 4-card problem with the letters and numbers is really analogous. It's very much the same between these 2 examples. So a lot of us, when we get to the 4-card problem, when it's just letters and numbers, we correctly figure out, okay, if the rule is if there's a vowel on one side, the number on the other side must be an even number, we pretty quickly figure out that, okay, we better check this A card to make sure there's an even number on the other side. But a lot of us make a mistake and we assume that if there's an even number, that there has to be a vowel on the other side. And that's really not what the rule states. And that's analogous to checking to see what a 22-year-old is drinking. We understand with the beer context that just because you have to be at least 21 to drink alcohol, you're not forced to drink alcohol if you're 21 or older. And so we know we don't have to check what this person's drinking. There's no point in it. But a lot of us will mistakenly think that we need to check the even number here to make sure that the rule is being followed, when in reality we do not. Most of us realize that we don't have to check the consonant because the vowel and even number rule does not involve consonants. And a lot of us miss that we need to check this card. This card could be out of compliance because the rule says if there's a vowel on one side, it has to be an even number on the other. So if it turns out that there is a vowel on the other side of this number 7 card, then our rule would be out of compliance. And that's analogous to checking the 16-year-old here to see what they're drinking. So we do this type of problem fairly well when it's about drinking age, and pretty poorly when it's a very abstract problem. And so let's go back and look and see that only 4% correctly identified the A card and the 7 cards as the ones that have to be turned over. So performance is much, much better with this context, 73%, versus without a context, only 4%. So what does this suggest about our reasoning abilities? First off, how important is the context and why? So to kind of think about this a little bit, remember System 1 versus System 2. Does the familiar context help us reason by maybe activating relevant information in long-term memory? And so I think that it's useful to realize that when we are reasoning out the abstract problem with vowels and numbers, or letters and numbers, we are really solving the problem using logic. However, when we have a familiar context, like we do here with the drinking age, we really don't have to reason the problem out for the first time. We've probably reasoned this problem out many times before in our lives. So the context allows us to be able to activate relevant information that we already know and apply it to this particular problem. So that's one really nice thing that System 1 does, is it kind of helps us go with what worked last time, go with with the most readily available information that we have. And so System 1 is helpful to us when the context gives us a way to solve the problem using familiarity as opposed to actual logic. And so we can interpret these types of studies and similar types of studies by saying that we sometimes reason better when we are able to use a schema, right? And the schema activates relevant knowledge and relevant information that allows us to more quickly sort of get to the answer. One schema we can use is called a permission schema. And so let's take a look at a permission schema here. Here it's about high schools and cities. The schema example is that only students who live in Grover City may attend Grover High School. So that's the rule. Only students who live in Grover City may attend Grover High School. If a student is to be assigned to Grover High School, then that student must live in Grover City. So we can look at this problem and go, okay, only students who live in Grover City can attend Grover High School. So do we need to check where the students in Grover High School live? Yeah, right? So we want to flip this card over and see where this individual, for example, lives. Now, do we need to check the students in Hanover High School? No, the rule doesn't say anything about Hanover. It doesn't say that a kid who lives in Grover City must attend Grover High School. Maybe they can attend Hanover High School. It's not prohibited by the rule. So we don't really care where a student lives if they happen to go to Hanover High School. We also don't necessarily care, again, what high school someone who lives in Grover City is, because they can go to any high school. The only prohibition is that a student from the town of Hanover is not allowed to attend Grover High School. So we need to check this individual, flip this card over, and see what high school this individual is attending. So we need to check the other side of this first card to see where someone attending Grover High School lives, and we need to check the other side of this card, the last one, to see the high school that this student who lives in Hanover, what high school they're attending. There's also, by the way, a social contract version that gives a little more background, so take a look at that. Some evolutionary psychologists have found that we reason better when the context is one of identifying, say, cheaters. That's like the social contract one or the permission schema. And others have argued that we develop sort of these pragmatic reasoning schemas just through our life experiences, that it's not necessarily an evolutionary advantage to identify cheaters. It's just we have a lot of experience. And so it's hard to distinguish between the two. But the important point is that having a context can definitely be very helpful in these types of reasoning problems. So to summarize the information we've looked at in terms of logic and logical reasoning, we can see that logical reasoning may require use of system 2 and can be interrupted by multitasking. So logic may require us to think about things sort of methodically and analytically, and that requires resources that can be interrupted by multitasking. We also saw that familiar context can help when the problem is familiar. People commonly rely on these reasoning strategies that are different perhaps from the principles of former logic. So we use strategies because they've helped us in the past, or we have some familiarity with that context. And that a permission schema is an example of reasoning really without using formal logic. We're using a different approach that relies on our experience with providing permission.